So the question has been asked in AIPMT 2015. It says two particles A and B move with constant velocities v1 and v2. At the initial moment, their position vectors are r1 and r2 respectively. The condition for the particles A and B for their collision is. Alright. So in the question, what we're given with is that we have two particles, one is A and one is B, and they're already at certain positions and their position vectors are given by r1 and r2. So initially when t is equal to 0, let's say something like that, A is at this point, B is at this point, and their position vectors are given to us. Now, after some time, they're also moving with constant velocity. So at this point, they start moving, and at this point, B also start moving. A starts moving with velocity v1 and B starts moving with velocity v2. We have to find out the condition for their collision, right? So we know that A is already r1 meters away from the origin. Now when it's moving from velocity v, when it's moving with velocity v1, it's going to cover another certain displacement that we know that displacement is going to be speed into time. So it's going to be v1 into t if we assume that the collision occurs at t seconds. And then for the same for the B1, we know that B is already 2 meters away from the origin, and when it starts moving with velocity v2, the displacement that it covers in certain time t is going to be equal to v2t. Right? So for collision, we know that their final position vectors should be the same. Position vectors means that this entire position vector should be equal to this entire position vector, only then will the two particles A and B collide. Now, if we talk about the position vector or the final position vector for particle A, the final position vector for particle A should be this plus this. Its initial position vector plus the position vector that it has covered at certain time t with velocity v1. So the final position vector, that is this point, is going to be equal to r plus v2t. So the final position vector for A is going to be equal to r1 plus v1t. And the second one is r final, that is the final position vector for B. If we talk about B, initially it was r2 meters away from the r2 units or meters away from the origin, and finally with velocity v2 it covers a certain distance, that is v2t, to reach this final point, same as that of A. So the final position vector of B is going to be equal to this r2 plus this v2t. So the final position vector for B equals r2 plus v2t. Now what we did here is that we transposed values from the right hand side to the left hand side. What we said here is that we brought position vectors along the same side and velocity vectors along the same side. So we had r1 and we transposed r2, so it's minus r2 equals v2t minus v1t. Now what we do next here is that we take out t as common, and we have v2 minus v1 equals r1 minus r2. Now for now, let's leave this particular equation as equation 1 and let's focus on this t. Here the time, which is basically the time for collision, the amount of time that is taken for the collision or for the two bodies or the two particles to meet, that's given by t. Now this t is going to be equal to r1 minus r2 divided by v2 minus v1. Now whenever we're dividing vectors, we always have to put them in modulus because we can't divide vectors, so we're generally dividing their magnitudes, right? So r1 minus r2 divided by v2 minus v1, but both of their magnitudes, that's going to be equal to the time at which the two bodies are going to collide. Now coming back to equation 1, what we're going to do is that we're going to substitute the value of t in equation 1, that is this very equation. So r1 minus r2 is going to be equal to v2 minus v1 multiplied by t, and we know the value of t, that is this. So we substitute in this value along with the modulus, because we cannot divide vectors, we can divide their magnitudes. Now if we bring in the position vectors from one side and the velocity vectors from the other side of the equation, we get that r1 minus r2 divided by modulus of r1 minus r2 equals v2 minus v1 divided by the modulus of v2 minus v1. So these are the conditions that are necessary for the two particles A and B to collide.